push that rock here with Simpson math. Let's talk probability. So let's think about an experiment where we have this urn and it contains some balls and they're black and white. And we're gonna pour out 2 of them. Now, if you're pouring them out 2 at a time, that means you're drawing 2 and you're not replacing them. So it's the same as pulling in, drawing 1 out, and then keeping that one in your hand, going in and pulling out another one. So it's drawing without replacement or selecting without replacement. And the experiment is to observe the color of the balls. So our sample space is, in this particular case, where there's only black and white balls, so we could get 2 blacks, we could get a black with a white, and we could get 2 whites. Now this is not a symmetric sample space, but it is all the things that could happen if we're observing the color of the balls. Now I'm going to talk about an event. An event is a subset of this sample space, and the event is alike colors. So if the colors are alike, that means we either have 2 blacks or we have 2 whites. And the question in this video is, what is the probability of alike colors? So to do that, I'm going to admit that the probability of alike colors is the probability that we get a pair of blacks or that we get a pair of whites. Okay? Now, or usually means add, and sometimes it means subtract if there's some overlap, but there's not going to be any overlap between 2 blacks and 2 whites. You're either both black or you're both white. There's not anything in this set that's also in this set. So now I have to find the probability of getting 2 blacks. Well, that would mean that we have to select a black and then with our second draw, select a black. So we're going to get a black and get a black. Or we're going to get a white on our first draw and then on the second draw, get a white. Now I'm using kind of sloppy notation here. I should say, I'm using B both to represent a black on the first draw and B again to represent black on the second draw, but that's, you can follow along. We don't need to get bogged down in notation. So what is the probability that I get a black on the first draw? Well, notice there's 1, 2, 3, 4, 5, 6 marbles. So there's 6 total chances and 4 of them are black. Okay. Now I've taken one of the blacks out. So that leaves only 5 balls left. Okay. And there's 3 of them are black. So there's 3 chances out of 5 that the second one is black. And when you hear and, we multiply. So we're going to multiply here. And with or, we're going to add. Now, what's the probability I get white on the first draw? Well, there's 6 total balls, but 2 of them are white. And the probability of getting white on the second draw, well, now there's 5 balls left because we've taken a white out. And how many of them are white? Well, only for 1. So on the second draw, there's only a 1 in 5 chance, assuming you drew out a white the first time, there's only a 1 in 5 chance on the second draw. So now we just do the arithmetic. So, I like to reduce when possible. This is 2/3. And 2/6 is the same as 1/3. Here we see a common factor, so that goes away. And now we can multiply straight across. 2 times 1 is 2, and 1 times 5 is 5. And then over here we have, oh, maybe I shouldn't have reduced because look, I'm gonna get there's nothing I can do. I can't reduce over here, so I'm gonna get 1/15. Well, now I need those 3's back. So let's put those 3's back in. That was silly of me. So maybe don't reduce all the time. You get 6/15 plus the 1/15. And the probability of alike colors in this situation is 7/15. Math made simple. Simpson math.